Alright guys, in this video we are going to go over the test questions from Unit 3. Now this was the same test from the volume, it's just we took it on the same day, but these are technically Unit 3 topics. So the first topic is parallelogram properties. In a parallelogram, opposite angles equal each other. So A and C are the same. You have to set up an equation that says the information in angle C is equal to the information in angle A, because we have to solve this equation for x. So 9x minus 4 has to equal 50. So from here, if you have a calculator, you can just do y1 and y2. Type that in y1, type that in y2, zoom out until you see the red and the blue cross, and hit second trace 5, enter, enter, enter. I am going to do these by hand. So add 4 to cross that out. So 9x is equal to 54. Divide both sides by 9, and x is equal to 6. All right, and if you do second trace 5, enter, 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 you would get intersection x is equal to 6. To find angle D is one of the next door neighbors. So that's a consecutive angle. And you should be able to tell these are not the same size. This is an acute angle and D is obtuse. So think of what else have we done. If they're not the same, what was the only option that we had? The only other option is that they add up to 180. And so when they're next to each other on the same side, they have to add up to 180. So 50 plus whatever angle D is has to add up to 180. So I'm just going to do 180 minus 50. 180 minus 50 is 130. So D is 130 degrees and B is 130 degrees. All right, rectangles is really the other parallelogram that we focused on. In a rectangle, all the same rules apply, but the diagonals are equal to each other. So PQ is one of the diagonals. From P to R is the other diagonal, and they give us the information here. They give us what PR equals, and they give us what QS equals. And those diagonals equal each other, so I need an equation that says those two things are the same. So what will my equation look like? What equation will show me that those two have to be equal to each other? All right, so I could put this in y1, I could put this in y2. When I see the blue and the red intersect, second trace 5, enter, enter, enter. I'm going to work it out by hand. So I'm going to subtract 9x on both sides first. Bring down that 1. That'd be 4x minus 11. So now I always want to get rid of the stuff that's on the same side as my x. I'm going to add 11 to both sides. 1 plus 11 is 12, and divide by the number in front of x. So 12 divided by 4 is 3. And if you do second trace 5, enter, 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 you should get intersection x equals 3. Now this one wants me to find TR. TR is half of PR. So I'm going to take the number 3 and I'm going to plug it into PR. So 9 times 3 plus 1. 9 times 3 plus 1 should be 28. So the entire diagonal is 28. These two pieces are the same. So 28 divided by 2 is 14. So from T to R is 14. All right, so let's do a few more practice examples together. So you should have this sheet. All right, so we're not going to do every single one of these. We'll just find x for number 1. So I have x here, and I have x here. So what do I know about opposite sides of a parallelogram? They are equal to each other. So what equation can I set up that tells me these two are the same? 10x plus 14 equals x plus 77. y1, y2, and if you're still confused, the equal sign is what separates. Everything before the equal sign goes in y1. Everything after the equal sign goes in y2. Second trace 5, enter, enter, enter. I'm going to work it out by hand by subtracting x from both sides first. All right, and I already ran out of room, but I'm going to subtract 14 on both sides. So I'm going to do 77 minus 14. And I got 63. And then I'm going to do 63 divided by 9. And I got x is equal to 7. And so if you're using the calculator, you would get intersection x is equal to 7. All right, question number 2. I need to find x and I need to find y. The ones in opposite corners are the same. So 3x plus 1 is going to be the same as y, but that's not really something I can do yet because I don't know what y is. I also don't know what x is. So I have to look at the 107. I want you to think about and even look at the picture. Look at the size of angle 107 and look at the size of the y angle or the 3x plus 1 angle. We only have two choices. 107 equals y or 107 plus y equals 180. Which one do you think is true? Because they're consecutive, they're on the same side, 107 plus y equals 180. So 180 minus 107 is 73 degrees. So now that I have an answer, I can set up an equation to solve for x. 3x plus 1 equals 73. Those two are opposite, so they are the same. So 3x plus 1 equals 73. This is a new problem, so I'm just going to draw a little line. So you can y1, 3x plus 1, y2, 73, find where they intersect. I'm just going to subtract 1, so 73 minus 1 is 72. And then divide by 3. 72 divided by 3 is 24. So x is equal to 24. All right, we didn't do problems like number 3. All right, rectangles. If ABCD is a rectangle, from A to C is 7x minus 6. That's a diagonal. From B to D is 74 minus 3x. In a rectangle, what do I know about the diagonals? So when I go to set up an equation, my equation can look like 7x minus 6 equals 74 minus 3x. They equal each other. So y1, y2. I'm going to work this out by hand, so I'm going to add 3x to both sides. Add 6. And when I divide, 80 divided by 10 is x is equal to 8. And if you do y1, y2, second trace 5, your intersection will be x is equal to 8. So now it wants me to find AC, so I'm going to plug 8 in for x. So 7 times 8 minus 6 is 50. And now BE is only half of the diagonal. So these diagonals are the same. So if I got that AC is equal to 50, then I know that BD also equals 50, and half of 50 is 25. All right, so do the rest of the problems as your test correction.